welcome everybody. Before I go into my talk about the patterns of Basecamp's application architecture, a little announcement. About an hour and 20 minutes ago, we released release candidate 1. As well as branched for Rails 4.0 stable. So we're really close to having 4.0 done and shipped, and it would be awesome if everybody who's here who's going to work on Rails code during the next 4 days could try it out, because that's the best way for us to figure out what's still missing or bugs or whatever else have you. And we sort of have almost this pattern of putting out betas and release candidates, and then we ship the final version and 50 tickets come in with obvious defaults or things that are broken. So it'd be great if 4.0 could come out, and for the first week or two at least, we wouldn't have to ship an update. So if you guys can help us do that, that would be amazing. OK. So the story of Rails is in many ways intertwined with the story of Basecamp. This is a screenshot of the very first version of Basecamp that we released in 2004. I started working on Basecamp in 2003 before I had any aspirations of working on Rails, before I had any ideas that what I was going to work on was going to turn into a framework. So the whole approach with Basecamp and with the creation of Rails was that I was interested in an application. I was interested in building something. The fact that I had to build my own tools to get there was sort of secondary. It certainly wasn't the primary objective. And that led to, in some ways, unique style of working, I think, that we've really embraced as a community and in Rails core, that frameworks are not inventions. They're extractions. We don't sit down and try to come up with features that we could need or we would want. We build applications, things that actually have to run in the real world, things that actually have to matter to somebody, not example code. And from there, we see, oh, what are the pieces that we keep using over and over again? So for me, that's why Basecamp is so important. Because just about, for sure, every single good feature I've put into Rails have come from Basecamp or Basecamp derivative. A few bad features came exactly when I thought that I could invent good frameworks. It never really worked. The question we're asking ourselves is not what would someone somewhere might want to do with Rails. Because that sort of speculative development style, we've had to work. I had to work with a lot of tools that were built like that. Teams assembled just to make tools, with influences of listening to people in various places, but with the core motive to just build tools. And that was what I was running away from, in many ways, as it came to Rails. I didn't want something built by somebody whose sole occupation was just to build tools for me, because those tools tended never really to match the expectations I had for real-world development. So what we do instead is say, I'm not going to care about anybody else right now. I'm just going to focus on building Rails as the perfect framework for building Basecamp. That's my mental model. The side effect is that Basecamp, of course, is not that special. Most of the things that it does, same kind of things you want to do in a lot of different applications. But because we attack the problems from this sort of concrete approach, we get to extract something that just feels right. Something that feels like somebody's actually used it in anger. And I mean, I've sworn and cursed my fair amount at Rails at certain times. So I've certainly used it in anger, and I've certainly changed things in anger. And I find that that's really where a lot of the magic happens. When I'm so fucking annoyed that something takes 4 lines of code when it really just should take 1, that's when good stuff happens. And it happens in a sort of a different way than that example code-driven development style that you often run into when people do this for a full-time living. Because it's very easy to make pretty examples. And we have lots of this in Rails where, for example, the standard scaffold for a long time, it looked like it was not very dry. It had a lot of duplication, right? And people would often come to Rails and they would say, as the first thing, well, this code you're generating it's verbose. I could optimize it in all these ways, and a few people have tried with various gems, and what you find is, yes, you can make example code really pretty by making a certain set of choices. Those same set of choices are usually the ones that makes it horrible for actual real-world development. Okay. So, 2003, 2013, I've been working on Ruby on Rails and Basecamp for 10 years now. That's about a third of my life. So I don't think it's any stretch to say this is my life's work, at least up until this point. And it's funny because in some ways it feels so familiar. When I look at Rails code today, it looks and feels and smells very much like the Rails code I wrote 10 years ago. Of course, it changed in a myriad of different ways, and it's much, much better now. But the kernels and the principles are very much still the same. And that's interesting to reflect on when you compare it to the things that changed. In 2003, this was a state-of-the-art phone. Seriously, flip phones was really hot back then. And it's so funny because that seems so far away, right? It seems like flip phones, I mean, that's another era, which it is in many ways, because many parts of technology move really fast. So it's interesting that we're here today and we're discussing and debating and improving a framework that's from the time of flip phones. So that's sort of like the form factor of actually a lot of people interfacing with our applications today go through phones. If we look at other parts of technology, just sort of the hardware we were on, I looked up these prices yesterday and it was like, half a gigabyte costs $50. Now you can get 16 times as much RAM for almost half the price. That's more than an order of magnitude change. Which is just, it's one of those things that's also interesting in terms of what does that change with how we approach things. Oftentimes, people will almost lock their concept of what hardware costs and how it runs to the time they entered programming. If something was scarce and expensive at the time they got into programming, they'll think that that's how it's going to be forever, which, of course, this shows when you can get 8 gigabytes for $29, how much RAM you use probably doesn't matter as much as a lot of other things, which is funny to me because that's always been sort of Matt back in 1993, 20 years ago. 20 years ago, Matt started working on Ruby. He had to care for, I should actually have looked up what RAM cost back in 93, but I'm sure it was fucking expensive. Yet, he sort of had the foresight to think, well, I don't know if he had the foresight, but it turned out that the thoughts that he was thinking about how we should make programming languages and development environments, like I can make something now that, okay, it's going to take more memory, it's going to be slower, and it's not going to matter because those things are going to improve drastically over time. What's not going to improve is programming brains. They're pretty much as mush as they were back in 93. So we need to optimize for that. So that's sort of the hardware side, that moves really fast. Okay, not that, I mean, we know that, Moore's law and all, right? Also funny to look at the things from 2003. Java was actually a real thing that people non-ironically wrote. Like, this was actually what we were, when Rails first came out, I was talking to a lot of Java programmers, and this was, they were serious. And it's just funny to think back about this sort of battle or whatever that we had in the beginning, and that this was the relevant foe. This was who we were trying to sort of say, there's a better way to implement a lot of the good ideas that you have, because that was the second funny thing, of course, is that Rails is from 2003, and the bulk of the thinking about how to structure and create nicely factored web applications, other types of applications, came from the Java world. It's just that they were trapped inside that beast, and we had to liberate it. So there are still people programming Java. Of course, the JVM lives on, and it seems like that has a long and prosperous future, and people are putting it to much better use than the Java language itself. The other thing, Struts, that was actually a serious framework at that time that we were sort of trying to convince people why this was better, why XML sit-ups and so on were not something you should have to do. So it's really interesting to think about all these things that changed and how much the world of technology has changed in the 10 years that Rails has been around. And I've been trying to reflect on why that is. Why are we still here? Why didn't Rails go the way of Struts? Why wasn't it just a footnote in sort of a progression of things? And where were all these other things that were supposed to come afterwards? I certainly never thought when I started working on Rails that I'd be here 10 years later and talk to 1,500 people at a sold-out conference. That's a pretty measurable success. That's surprising, I'd say, in technology. Just like the flip phone is not here anymore, and Struts, thankfully, isn't either. You should have thought that Rails would have gone away, right? So I think the stuff that I talked about last time, or last year, that pioneering spirit, I think is what makes the Ruby community and the Rails communities unique. We are willing to continue west. We don't just stop when we find a comfortable resting place. There's a lot of other communities that value stability far higher than we do. That's not to say that stability is bad. It's a trade-off. If you look at, say, the Python guys and how long they've taken to get on Python 3, they're not there yet, by the way. They're still going. And it's been years, right? How long did it take the Ruby community to move from 1.8 to 1.9, from 1.9 to 2.0? And it wasn't because it was painless. How long did it take the Rails community to move from Rails 1 to 2 to 3 to now 4? Again, it wasn't painless. Anytime you want to make progress like this, it's going to hurt. But we as a community are willing to take that hurt. And I think that makes the community unique. We're willing to sacrifice for progress. And I think what's interesting about that, the pioneering spirit, that we're willing to continue west, that we don't just stop halfway and say, fuck it, Kansas is good enough. A lot of people they stop in Kansas. Like, that's just like, things are fine. I mean, I have my cows and the sun comes up in the morning, great. I mean, although some Rails people have stopped in Kansas. Just to be clear, there are still a few people still running. This is the half-life of Rails of where we are right now. Came out in 2009, that's 4 years ago. Anyway, so if you're still in Kansas, keep going west. California awaits you. The West Coast awaits you. Portland, I should say, actually. My bad. So we've continued west. We've gotten closer and closer to this sort of promise of the West Coast. And I think as we've gotten closer and closer to that, as it's taking years and years, because this, again, it's a painful journey, it's a perfectly legit thing to say, I'm just not interested in any more progress. We're stopping in Kansas, and I will go on, and I will do Rails 2.3 for the next 4 years. A lot of people did, and it wasn't like they were necessarily miserable. I mean, people do lead good lives in Kansas. But I think that there's something more important here to keep on pressing on. And not just because we keep our own interest and this is still interesting to go to. If we had just stopped as a community and said, Rails 2.3, that's our final resting place. Ruby 1.8, what did we end at? 1.8.9? 1.8.8? 1.8.9. Whatever it was. That's the final resting place. That's where we're going to stop, right? That's just where we're going to park our ambition and say, that's good enough. I don't think we would be here, because then these things would just be tools. Nothing wrong with just being a tool. There's just something more inspiring about pressing on and going further. About this whole notion of pressing out and going further. Joel Spolsky in 2001 had this great essay, "Good software takes 10 years, get used to it." At the time I read that, it was funny. I read that and it's like, what a fucking jackass. I can make something in fucking 6 months that's going to blow the doors off whatever you've been working on for 10 years. But I think he actually had the long end of something. You can build something that's good for you in 6 months, and it can be good software. If you want to build something that has the kind of impact on community, on the programming community, on the world, for lack of a less sort of grandiose vision, it does take a long time. We've slowly but surely built this up over time, and that goes both for the work that I put into Basecamp and it goes for the work that I put into Rails. These things compound slowly over time if you keep investing in them. You can see the sort of progression of investment that we've had with Rails and the people who've been flowing into it on this chart. New contributors with their first commit to Rails. So 2004, first time I opened up the code base and accept patches and let other people commit to it. A few people, 40 people, I think, had a patch going to Rails in 2004. Very next year, big boost, 280 people or whatever. Then we sort of had like I don't want to call it flat face because this is all new people coming into the community and starting to add something. But for a long time, we had sort of a steady rate of new people joining the community. And then something interesting happens. 2009, there's a small dip. Everybody thinks the world's going to end, and everybody's getting fired. And all right, I understand. And then after that, what happens? There's a massive jump. And this is actually funny because this is actually, so 2009, our Kansas, so there's a baseline there, right? We keep pushing. And people respond. A lot of people are interested in pushing on with us, is interested in joining the caravan and continuing on, which is really just sort of interesting to see the phase that we can go through. By the time 2009, I've been working on Rails for 6 years, and we sort of had this steady inflow, and then all of a sudden, lots of people get interested in getting involved. Awesome. If you look at the same, did I actually not have the chart up? No, I did. If you look at the same chart, just compounding all the commuters, you can see it's a little bit more of a steady climb, but the same pattern is there. From 2009 and onwards, lots of new people got involved because we kept pressing through the comfortable phase. Even though, the funny thing is, when you do that, you sort of, we have the saying with Basecamp where you shouldn't be afraid to let customers go. Sometimes customers are going to outgrow you. They're going to think, like, well, you no longer represent what they need in a project management application, right? A natural reaction to a lot of people, or for a lot of people, is to look, shit, we can't let that happen. No customer can leave. Lock the doors. We will do whatever we can to make them happy. We had that moment in 2009 where we could have said, let's just lock the doors. Let's just improve things for all the people who are already here. Big enough community, we're comfortable, we could be self-sustaining for a long time, that'd be fine. Where we instead said, nope, we're going to keep the doors open. What that's going to mean is that there's going to be some people who are unhappy. Some people, I've heard people say, Rails 2.3 is the best version of Rails ever made. Which is sort of one of those funny, nostalgic things of sort of you just lock your time zone like the 80s. That's when music peaked. And it's just such a funny phenomenon, but it's very real, and I think that's where a lot of technology circles and ecosystem, they stop. And then they just stay there for the rest of the line. Anyway, we pushed on. here are the stats for the last 12 months running. More than 1,000 people were part of more than 8,000 commits to Rails GitHub repo. That is fucking amazing. 1,000 people working, and this is just the people who get commits in. We have so many more people doing all sorts of other stuff around the code base. This is just the people who got to commit into Rails itself. That is really and truly astounding. And I think that shows and validates the approach, the uncomfortable approach that we have to keep pushing and keep getting better, even if it will ruffle the feathers of the people we already have, the customers, the developers that are already using Rails that are sort of somewhat uncomfortable with whatever new direction we have. It's also a funny match to Roger's innovation adoption curve idea. This is sort of an analysis describing how products are adopted. So obviously, from the beginning, we had a lot of innovators, like people who just would use Rails, even though there were a lot of things that were broken or didn't do whatever in the beginning, small slice of the overall market of developers. Okay, we got the early adopters. I think that's our sort of first crest. And then you sort of hit this point where you have to make the jump from early adopters to the early minority. And I think that's exactly what that point in 2009 shows us, that we did make that jump. We are now on sort of the next ride up, which is pretty cool. And I think it's also interesting for me in the original reason that I got into open source, the original reason that I wanted to release Rails was twofold. First, I wanted to give back. I'd been using Ruby, I'd been using Linux, I'd been using MySQL, I'd been using Apache, I'd been using all these open source projects. So when I had something myself to share, I felt like, dude, you're a dick if you don't release something like this that other people could find value in when you've used all of their stuff. So there's that. Don't be a dick. And then the second part is I'm having a lot of fun doing this stuff. Ruby is really a great programming language. Rails enables me to use Ruby to build Basecamp. There's going to be a lot of other people out there who could benefit from Ruby. So let's get as much programming joy out there in the world. And that's why this stuff is interesting, because we are having a bigger impact. We're getting more people involved with enjoying their work and not being stuck in Struts or whatever painful torture instruments of the time. Anyway, so I think that's all great. And it's great to see that more people get involved. But you also then have to stop and say, OK, what are we actually doing here? What is the purpose? Why are we still working on this? What is the improvement path? Who are we? And who do we want to be? So I think a while back, decided we want to have a big tent. There should be room for a lot of different people in the Rails community. Jugglers, magicians, clowns, and elephants. All invited. Come on. And we pulled some things in. We did with Rails 3, we had an influx of good new ideas from at the time, a competing framework called MERP, which was sort of a good reflection of, OK, it can be a big tent. We can have room for a lot of people in here who might not agree on everything. They might not all want to build Basecamp, but we have a general principle, a general purpose that this is where we're going, and we agree on these things. And then once we sit down and actually work on code together, we realize that we share more opinions than we don't. But even so, even if you have a big tent and you have room for jugglers and elephants and so forth, and you're having fun, you're not a Ferris wheel. Like there's got to be something you're not. You have to sort of define it in some sort of or position or say that there's limits to what this is. Because if you try to be everything to everyone all the time, you're nothing to nobody none of the time. Not a great place to be. Second, the title of this talk is Patterns of Basecamp's Application Architecture. The whole idea of patterns is that you see a problem and there's a solution, but there's a third element. There's a context. There's a context in which that problem arises. Because you can encounter the same problem in two different contexts, and you're going to want two different solutions to that. So what is the context? What is the context of Rails, of the work that I'm doing on Basecamp? For me, that context is dynamic hypertext documents. What does that mean? It means that this is sort of what I'm trying to produce. It's funny because when you see HTML, it looks like it's such a, there are books like Learn HTML in 4 days, right? It seems like such a low-level thing. It seems like such a simple thing, such a sort of beneath us kind of thing. If we are serious programmers who do serious work, like all we're doing is just generating HTML, that's, I mean, come on. That's for HTML monkeys, right? Like, I need something more grand. Well, to me, the grandness is embracing this simplicity, is embracing what the web is. And not just the web and HTML as a delivery mechanism. Sort of, the web and HTML has a lot of sort of side effects that are neat in terms of software deployment and development. Don't have to install software. You just get it from one place. You can deliver a lot of different kinds of software where you just use HTML as a delivery mechanism. But when I've been revisiting and going back through the Basecamp code base, and especially the work I've done with the new version of Basecamp, I realized that it's deeper than that. That this is not just a delivery mechanism. The actual structure of HTML, the approach to the context of software development as a document is profound. And that profound approach is not something we should try to escape. It's something we should try to embrace. So you can think about a lot of different applications that are being delivered on the web as sort of on a continuum. On the one end, you have something that's basically a purely document-based. And on the other hand, you can have something that's almost like a GUI using HTML as a delivery mechanism, but certainly wouldn't describe it as a document. I think if you look at that sort of continuum from document to GUI, and nothing falls perfectly at either end, perhaps these two. I mean, Wikipedia is pretty much just a collection of documents. It's a pretty good map to, I think, my vision at least, of what I'm interested in, the kinds of application I'm interested in, and thus the kinds of tools that I'm interested in building. I want to build tools for a document-based web. That approach to software development is quite different from all sorts of other approaches that went before. If you look at software from before the web, it looks different. And I've been struggling to find a word to describe that style of applications. GUI is the best I can come up with, even though, of course, the web is a GUI too, but you sort of know what I mean. Maybe it's easier if you look at an example. If you look at Google Maps, for example, that doesn't feel like that's a document. That feels like this is using HTML as a delivery mechanism for the application that it provides. Doesn't mean it's not a great application. It is a great application. It just means that if what we're trying to do is optimize for a version and a vision for web applications that is more document-based, this is not the primary thing we should optimize for. So if you're trying to write the next Google Maps, maybe Rails, at least as a whole package, as a full stack framework, isn't the natural fit. You can pick parts out, and you can have a good HTTP processor, and you can do all these other things. That's interesting. So if that's 100% the camp that you're in, the sort of not related to documents at all, then maybe that's not it. Then it becomes interesting because, as I said, few things are either one thing or another thing completely. If you look at Basecamp, for example, we have this calendar there. That doesn't feel very much like a document. It doesn't feel like it fits HTML. What's the section? What's the header? What's the paragraphs here? It feels like we're using HTML as a delivery mechanism. But it's minority thing part of what we do. So we sort of try to fit it in and decide, and it should be possible, but it's not the main thing. The main thing is more stuff like this, where it actually does look and feel like a document. This looks and feels like something you would not have before the web. This would not be like what an application looked like, because this is that native development style of the web. If you look at something like GitHub, it's the same thing. It feels like a document. It feels like it's a document that's decorated with some dynamic behavior, and that's great. But the key part of it, its essence and its being, is the document itself. It's not just a delivery mechanism. So that's the slice and the part of information technology that I'm interested in. That these kinds of document-focused applications are not a bad thing. It's not something we should be trying to escape. The constraints that it puts on us to develop applications in this style, they're liberating. They're not bad. We don't want to start with an empty canvas and have to draw everything up from scratch. The fact that HTML is there and gives us sort of semantically relevant containers to put certain things in is a benefit. It's great. And that's where, I guess, the insight for me is that why is it that I was never interested in Java applets? It wasn't just because like it was Java, like, it's horrible enough in itself, but it was the notion that this was just a blank canvas. You can draw whatever you want. There are no limits here. You don't have to fall in line to some pre-described notion of a document or set GUI elements for a document of forms or so forth. You can do whatever you want. I don't want to do whatever I want. I want a container, a base, to put my ideas in. That's when I find that they flourish. So with that insight in mind, and with the insight in mind that the web is the most successful software development platform of all human history, that leads me to think that it's actually not that big of a surprise that this failed. Because the architects of this sort of canvas-based, let's use the web just as a delivery mechanism for the same application architecture ideas that we had on the desktop, they're wrong. That's not the part of the web that's interesting. It's not just these accidental properties of, oh, it's easy to update software because it runs on my server. The things that brought the web to its prominence with users and developers alike were the constraints. Was the fact that that style of interfacing with information technology is really user-friendly, it's very development-friendly, it's different, not in a worse way. And that's usually what I had a conversation, I think it's RailsConf maybe 7 or something, and some Microsoft guy was coming up and he was going to tell me about Silverlight. And the pitch was, I'm finally going to free you from HTML. Like, imagine if you weren't bound by paragraphs and sections and divs and so on. Imagine all the things that you could build. And he genuinely believed that that was what was holding the web back. The fact that it was delivered through HTML, and if we could just be free from these constraints, everything would take off, right? And it would be so much bigger. When you're failing to realize that the thing that already took off was the web. And so you had the first attempt, Java applets, then Flash, same idea. Same idea, if the web's constraints are terrible, let's start with this open canvas where you can build whatever the fuck you want. And then magic is going to happen. Magic didn't happen, and Flash today, I guess it's games and video players with DRM. Then in the universe there. Silverlight, same thing. Oh, the problem isn't that that it's the canvas, it's that just the development experience or whatever. We should use a better language, then all our problems will be solved. developers will flock to it, and users will rejoice. Didn't happen. The web won out again. HTML is still around. And then I guess the one that's a little more interesting, a little more current, is iOS and the current craze for apps, which in many ways is exactly the same thing. On iOS, you can start with a blank canvas. You can draw whatever you want. What are the top downloads in all the app stores and so on? Game, 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 fart app, game, fart app, game. Because the kinds of applications that we've been building for the web for the past, in my case, 10 years with Ruby on Rails, and in the case of the web, what, 20 years or a little more than that, since HTML and so forth came forth, not those kinds of things. And those kinds of applications are, that side of application constraints are still relevant. That's why we're still here. That's why we can still build these things. That's why nothing of either Flash or applets or Silverlight or, I think over time it'll show, even iOS and native apps have topped the web off the top space. Okay, so for the new version of Basecamp that I've been building, we took this even further. Even the visual look of the application embraces the notion of the document, of the page. It's a series of pages stacked on top of each other. It's a kind of application approach that you would not build with this sort of constraintless canvas-based approach. In essence, we decide to embrace the document, that the essence of the web and of HTML was the truly profound part of it. And the closer we could get to that, the closer our application actually felt like it just was hypertext documents with links going between pages that changed full things, the better off we were. Versus trying to embrace and deliver a more sort of GUI-based approach with panes and sort of fixed elements all over the place, and that would bring us joy and happiness. So this is about 2 years ago. I've been working on Basecamp for 8 years at that point, and we say, okay, this was actually up for debate, and this is where a lot of these sort of thoughts came from. Should we try to that? Could we deliver a better experience with that more GUI delivered via HTML as a delivery mechanism approach? Could that be better? And what I found was I wasn't actually interested in any of that. What I was interested in was evolving that document, bringing it up such that it feels like it's on par, such that it feels like it's a worthy competition for that kind of GUI-based approach. And what was it really I was competing against? I couldn't quite put my finger on it. Was it like the fidelity of the user experience? Is it like you can draw whatever you want? No, I think for large extents, what people like about native solutions, speed. They are fast. When you have to send less, it's easier to make it fast. So a lot of people were like, well, we want native stuff because we want fast stuff. Well, then the thought goes, well, wait a minute. Instead of throwing all of this wonderful development style, this document-based approach, this native approach to the web out just because we want speed, can we get the speed without doing that? And that became the focus of my work on the new version of Basecamp, and that in turn became the focus of my work on Rails 4. And I have sort of 5 patterns to go over that I use to get that speed, to evolve the document, stay true to the document, but bring it up to par with sort of that native approach. And whether native means actually an iOS app or it means a client-side JavaScript approach or something else like that, same deal. So the 5 patterns are, and they're sort of built in as a pyramid. They build on top of each other. First, to make things fast, especially to make things fast in a language that's not particularly fast by sort of natural endowment, you need to cache. And we've had a lot of different approaches at caching over the years, and they've all sucked so bad that it's sort of up there in like the last 2 hard things in computer science is caching and naming things. So caching, why is it so hard? It's so hard because you have to keep track of it like you had to keep track of memory management. When you have to keep track of how much memory you allocate and you have to release it and so forth, it's C and buffer overflow and all these other wonderful things that people use to amuse themselves with. It's not a very productive environment, and it's not a very welcoming environment. So to make caches work, we have to cut out the complexity of maintaining them. Because if they stay as complex as you have to manually manage everything, nobody's going to do it, and the few people who are going to do it are going to do it wrong. So they're going to have bugs. This is also called generational caching. I like to call it key-based cache exploration because that actually says something about what it does. Anyway, so in Rails, this was actually, I think, maybe in 3.2 we added this. The notion that every single model will have a cache key that can be generated automatically, and it's just based on a few things, like the name of the object, its ID, and critically, when it was last updated. So that's the trick. The trick is that you say you have a person object, and at a given point in time, that has a given key. That's what you use to look up all your caches from. When that person object changes, the key changes. You do not go back and look for all the places where that cache was used and try to figure out a way of expiring those caches. That's what we used to have if people were sort of old enough to remember the sweeper, which was this halfway observer where you would observe model classes and then it could also expire caches. It was a truly, I don't even know what to call it. It was a truly horrible experience to try to maintain that. Because it felt so easy. Oh yeah, when you save the object, I just go back and touch these 3 things, and you would always forget one of them, and then the user would see expired caches, and you couldn't replicate it. It was like, well, it works for me. Not a very good experience. So key-based cache exploration really solves all of that, because it takes it all the way back to the notion that you don't have to care who's basing a cache of you. You don't have to keep track of all that stuff. It will happen automatically. As the person object evolves, the cache key changes, and everything that's bound in that cache key automatically expires. Or it actually doesn't expire. It just is not used again. So that's the other part that we needed to make this work, was memcache, or something like memcache. I think Redis can run this mode too, where you basically say, throw out all the old caches that I have not touched in, well, throw out the oldest one. So that automatically just works in such a way that when you update the cache key, you're no longer accessing the old caches. Thus, they can just be automatically garbage collected. Thus, you don't have to worry about them, and you can just proceed with your merry life. Fantastic. Second part of that, or actually building on top of that, now that we've solved the complexity of cache exploration, now that we've solved that we're not going to have all these bugs anymore, we can grow our level of ambition. And that's really a good sort of comparable to Rails in general. We start out solving root level issues, root level problems. Then once we have that solution in place, we build something more ambitious on top of it. Then we solve that problem. Once we have that in place, we build something more ambitious on top of it. And that's how we can end up with a framework as pleasant and advanced to use as Rails, because it's sort of this layered cake. Well, next layer in the let's make shit go fast cake is Russian doll nested caching. Now that we can rely on these individual caches to not be a pain in the ass to maintain, we can build composites out of them. We can nest them deeply. I would never really have tried to do this with sweeper logic. I mean, just making a few caches was painful enough. Try to nest caches inside of each other, forget about it. But with the problem taken care of, it's really not a hard issue anymore. We can nest these caches inside of each other and make some really tall caching stacks, which have this great benefit of we only have to expire a little piece of it. When you just cache the whole thing, a whole page, something changes, and you have to throw out that entire cache, well, it's really expensive to recompute the entire page again, and then you can cache it, right? That's not really what you want. Only a little part of your document in this document-based approach changed, so that's only really the price that we want to pay to recompute. In Rails, we now have this idea of touching. So you can build these trees where a comment is inside of a post is inside of a project. If something changes in the comment, we will touch up all the way up the chain. If any updates happen, we will automatically bump all the updated fields on the parent objects. Again, we built in this automation where I just declare my hierarchy once, and now I don't have to know that if I change my comment, I also have to remember to change the project. Because that's kind of the same sort of problem we had with caching and dealing with that stuff. You don't want to maintain these things. You just want to deal and think about these on a one level at a time approach. If you look at, this is a page from Basecamp and how this is built on. It doesn't actually matter that you can't really truly see too much of it. What you can see is that there's a little blue box to the bottom of the screen that represents a single to-do item. That's a single cache, okay? Every single to-do item on that list has their own individual cache. That entire box, that entire to-do list, then has its own cache. That entire section on the page, all of the to-do lists have their own cache. That entire page itself has its own cache. We're now 4 levels deep into our nested Russian doll. And then what happens when this one thing changes? So the one to-do changes. In the old world, the whole page, throw it out, recompute it again. Very expensive, very slow. New world, you just bust every element above you. So a single to-do item is changed. We bust that cache, that busts its container, busts its container, and busts its container. But to recompute those containers, it does not have to recompute all the other stuff that we still have caches for. So to recompute the cache of a to-do list, you can reuse the caches of the other 9 to-dos that were already cached. You're just changing the one, recomputing that, and then compiling all the caches together. Like, OK, that turns out to be very fast. It turns out to be very fast when you're changing things, when you don't have to recompile the whole thing again. And second of all, it's now easy enough that you can do it without it feels like a complete pain. This is how it looks in the view. If you take the bottom layer, the comments partial, that's cached just based off the comment key. Because the other pain of caching was to try to figure out, of course, all the things that this depended on. In his new world approach to it, I always try to just make it sure that it just depends on one thing. Make sure you have your tree in line, and your cache should always just refer to one model object. And we'll deal with the variations in a little bit. But so here we have the cache partial. That's inside, then called from inside the post partial. The cool thing of the Rails 4 feature that we use for this, for the nested caching, is that what was hard about caching was both maintaining this kind of updating stuff when the models changed, but what was equally hard was what happened when the partials changed. When you evolved your design, how did you bust the caches to account for that? Well, we account for that automatically. In every single cache key that's used in the view, we compute an MD5 of that partial and include it in the key. So if you change the partial, we will automatically, along the same lines as if you touch the model, bust all those keys that depend on it. Not only that, we will bust all the keys in the Russian doll structure. So if you change the comments partial and the post partial includes comments as part of it and in its cache, that will be busted too, automatically. Because we actually look through the template file to find render post comments and say these two things depend on each other. Now we have a whole dependency tree, and every single partial can be changed individually, and we will automatically just bust the caches that depend on that. If it doesn't automatically match, for example, if you have your own implementation of render comments, you're not just following this default convention, you can manually declare a template dependency, and that'll be included in the cache and so on and so forth. OK. This is all part of Rails 4. It's part of an exploration I did with a plugin called Cache Digests. Is that what it's called? Yeah, I think so. Cache Digest. And it follows this natural way I've been developing new features for Rails by saying, well, first I will spike the pattern in Basecamp just as a plugin. If it works, we will extract it and move it into Rails itself. So the result of all this is that these are the performance stats for Basecamp for last week. The mean response takes 27 milliseconds, median 59 milliseconds, and the 90th percentile 155. That's pretty fucking fast. And it's fast because we're relying on all this caching stuff. And it's easy to work with because this caching stuff is no longer painful. We can build more things on top of that, but before we talk about that, we have to do one side direction. For all these caches to work so neatly, they have to be the same for most people most of the time. If you're just caching stuff for an individual user and every single user have their own cache, not very useful. Not a whole lot of reuse. You're not going to get those numbers. So what we've had to do is basically identify in templates all the places where stuff is different for different users and figure out a way to deal with that. Well, welcome JavaScript decoration to decorate our documents. So here is a timeline in Basecamp for updated events. Doesn't matter, you can't really see it. What it does have here is it has a time. It says 1:05 p.m. If we cache that time, it's going to be 1:05 p.m. whether you're in New York or in Portland. Not very helpful because it's not the same time at the same places. This is generally one of those things where you would just rely on whatever the user is. You would just say, well, event updated at, to string, it doesn't matter. I already have the time zone because I'm getting that, and Active Record would automatically convert that time zone for me, but we can't rely on this because we can't cache this. Because if we cache this, we're caching it in one particular user's time zone. So, no bueno. What we have to do instead, and this is really the pattern for all these caches, is we have to figure out, could we describe this data in such a way that it could be converted for the individual user at the time of render, so that we can reuse the caches and not have to keep different caches? Or, well, yes, we can. This is the approach we use. So instead of just saying, output the time in the specific time zone of that current user that's currently going on right now, we output a time tag that has the time in UTC, and then we have a JavaScript hook that just looks for these time tags, and once it sees that, it converts it on the client side into the latest time zone, or the time zone of the user. This works really well. Now you solve that problem. Okay, there are more of these problems. None of this progress was going to come easy. None of this sort of approach to it is going to come without some sort of sacrifice or change in your way of building applications, but that's okay. Next problem. So here you have a to-do list in Basecamp. You have a bunch of controls: edit, delete, move, copy. Well, not all people at all times are allowed to edit a to-do list or a comment as it is down below. So how do we deal with that? In the old world, we will check permissions on the current user. If current user can change to-do list, show these links. Well, here's that problem again, current user. We can't use that. So we have to figure something else out. Now, when it comes to these things where it's just a link, where the permission is actually not on the action, but on presenting the action, we can say, okay, we don't need to do that. What we will just do instead is we will always show the link in the cache. For everybody, we'll see the link. But what we will do is we will decorate that link with something like data visible to admin or creator. And then, just as with the time setup, we will have a little piece of JavaScript that will go through, look at all those links, and say, oh, you're not an admin, you're not the creator, hide the link. Again, it doesn't matter in this case because, well, it doesn't matter that it's shown in the actual document because who cares if somebody's going to do view source and see that there's a delete link. They can't click it anyway because you're going to force all this stuff naturally on the controller as well. So all you have to do is hide it. The one area where this becomes hard to make the full nested doll setup is when you can't actually show a piece of information to a user. So if you have a list of notes, and some of those notes are marked private, and you're not supposed to be able to view source and then view that note, this trick is not going to work. You are going to have to do more fine-grained caching, and you can't use the nested doll as tall as you want. We have a few cases like that in Basecamp, where when you're looking at cross-project stuff, we're pulling in topics, and you don't have access to all projects, so you don't have access to all topics, thus we can't show you the same thing. But even in those cases, we can still cache the individual lines, and we can still just group the things that we can cache when we can. And it's still a huge step forward. So when you have now this speed, when we brought the speed down to a mean of 27 milliseconds, when most things are happening below 100 milliseconds, there are now other bottlenecks that pop up and things that make the application feel not as fast as native, even though the server side is actually doing things as fast as it can. So you have to move on and figure out what's the next step. So my approach was, first I found a way with the caching to get us down to this level of speed for Basecamp, and it was like, this is great. Then I clicked over on some client-side MVC app, and I clicked around, and it's like, there's still something missing here. Why is this faster? Why does it feel like the whole change of the document is kind of slow, even though I can see on my server side, it's not because they're rendering their shit any faster. A lot of client-side MVC apps, if you look at how long it takes them to render the JSON, lots of them will spend 20 milliseconds doing that, or 50 milliseconds or longer. So that wasn't the problem. The problem was that they get to keep a persistent process of the whole JavaScript environment that they don't throw away between each section. Enter tuple links. Tuple links is a simulation of sort of a single-page app like that. That we will keep our natural way of building these document-style apps, but we're not going to throw the whole process away every time. It's a little bit like PHP or CGI, where there's nothing left over. That's the natural way. When you change a page in the browser and you're not running something like tuple links, the whole fucking environment is thrown out, just like CGI. You can set up all sorts of variables, poof, they're gone when the request is gone, just like PHP. It's gone when the request is gone, everything's gone. There's nothing to clean up after. Tuple links turns your app into a persistent process to cut down on this speed deficit. It's based on an idea called PJAX that the guys over at GitHub created because they ran into the same issues. They were trying to make the GitHub interface faster and sort of ran into this issue. Well, actually, it seems like there's something that takes a long time to change from page to page. The PJAX approach is based on the notion that if you look at a page, there's going to be some parts of the page that don't really change. You can look at a navigation bar at the top, doesn't really change. What we are going to just focus on change between links is just the body part of it, just one walled off section, and we can just change that. Well, as I was looking at that, I was like, this is curious to me. Why is it that slow to send down the navigation part of it? If you're sending down, the bulk of the stuff is in the designated div anyway, so maybe the extra navigation is what, 10, 15% of the data you're sending down? That's not the slow part. The slow part, and that's what led us to sort of look into, well, actually what's slow here is when you throw away your whole JavaScript runtime, and that's an aside here, but even though we're building this document-style approach, we have all these little JavaScript decoration bits, and they're a lot of code. We have 10,000 lines of CoffeeScript code for Basecamp. Maybe, I don't know, 3,000 of those or 2,000 of those are for that calendar that's sort of over its own. Everything else is for the decoration of these documents. So there's actually a lot of JavaScript running, even if we're sort of targeting this approach. Anyway, so tuple links just basically says, that's not the problem. The problem is not figuring out which little part of HTML should we send and which little part should we not send. Let's just send the whole damn thing, but let's keep the head. Let's keep the JavaScript process intact, and we don't have to recompute that. OK, great. Steve Klapnick did some tests on this, and there's some confusion about how much it's actually faster, and it certainly varies depending on how fast your underlying app is. But in the test he was running, it was between 20 and 70% speed increase. I actually never ran those tests. I didn't know that that was the actual speed. I just ran the apps back to back with it and without it, and it just felt way fucking better with it, much faster. It's going to feel faster the faster your app is. So that's one of those things where if you have a really slow app, it doesn't look like TurboLinks does anything for you. If you have an app that returns a response in 50 milliseconds, feels like a big deal. Final pattern. Even though we have these documents and we're changing them as we pursue links, one notion and one measure of speed is that things happen even if you don't have to manually do anything for them. So if you look at a page like this in Basecamp, it's a to-do item. Comments are popping in as people are making them. I don't have to reload the page. I don't have to reload the screen. I don't have to follow something else. It just pops in. That feels fast. So that's another sort of section of, that was what the notifications of native systems, they felt like they had this live element. That's part of what made them feel fast. We can recreate this really easily. The way I'm doing it is this approach. So the underpinnings of this is basically RJS. And not RJS as in use Ruby to generate JavaScript, but as in reply with fully formed JavaScript replies to an action. So that's what we do. We break it out in 3 elements. We have page updates, which means JavaScript updates that's going to go to both the person currently making the change and to everybody else listening on that page. So we record all these JavaScript calls. We basically compile a little bit of JavaScript. We stick it into a queue, and then we have everybody else who visits that page listen for that queue and poll every 3 seconds. Here are the local updates, things you only want to do for the local client, I guess you can call it. So these things are not recorded, not stuck into the queue, like closing the form when you make a new comment. It shouldn't close everybody else's form. It should just pop in the new stuff. And here is a remote update package that only goes to clients listening for this channel. When I sort of stumbled across this pattern, I was kind of amazed how little work it took, because I already had all this work. I had already lined out all these elements to do the Ajax part of it locally. Then the only thing I did was I started a recorder and recorded it all, and I sent to all the listening clients. I basically made the entire Basecamp app live in about 4 hours. Instead of building something else and sort of coming up with a different way of how do I track this and send it over, let's just send the same shit to everybody that I'm sending anyway for the Ajax response. And it turned out to work really, really well. Okay. And when I first built it, the intention wasn't actually to use polling. It wasn't just to troll everybody who thinks that polling is an outdated mechanism that you could make. I was thinking, oh, well, I just pulled in polling for now because that's easy. And then we can make it sort of some sort of live update or permanent persistent connection or something else in time. Well, that time came and that time went, and it wasn't necessary. And today, this whole system is running 100,000 requests per minute are polled through a couple of Rainbow, or 6 Rainbow workers and 1 Redis instance. So this is one of those fun things that kind of relates back to that chart I had for the RAM. Like, polling sounds atrocious because it sounds very inefficient. The thing is, inefficiency only matters if it's expensive to solve. We're terribly inefficient. Rails is a horribly inefficient framework. It just so happens to be that in 2003 that didn't matter. In 2013 it matters 20 times less than it mattered in 2003. It couldn't have worked in 1985, but so fucking what? We're not in 1985 anymore. Let's build stuff for the technology and the capabilities we have today. Let's trade off. Let's be wasteful in our programming cycles and memory usage as far as it doesn't matter. Okay. So these are basically the 6 patterns of the new Basecamp, and all of these approaches are, if not built into Rails 4, then very easy to do. I'll put up all the code. and we'll publish a little bit more about how we do the live update thing. It's very little code. The Rainbow worker that does the polling is half a page of code, and usually just saw basically the rest of it. So, thank you very much. This is my presentation.